What we see here depicts an object, for example a cart of some sort, pushing a resisting object. Let's say pushing another cart that maybe has its brakes on, or has some other means of resisting the first object. Now, if the first object exerts a force F on the second object, and of course if the first object is pushing the second and has a velocity in the indicated direction, then it will exert a force in this direction on the resisting object. If it exerts that force through a distance delta S, where delta S is the distance, the change in the position of the object from here to here. These dotted lines indicate the two objects after they've moved some distance delta S. Then if the forces S and F, if the force F is parallel to the displacement delta S, then the amount of work done, the change in the amount of work that's been done by the object, or the work done by the object over this displacement, is the product of the force and the displacement. It's equal to F delta S, provided these two are parallel. If they're not parallel, then you take the component of the force parallel to the displacement and multiply that component by the displacement. Okay, if we have a pushing force of, let's say, 200 newtons, then if we have a pushing force of 200 newtons and a displacement of 300 meters, then the work contribution over that 300 meters is delta W equals F delta S, 200 newtons times 300 meters, which gives us 6,000 Newton meters, and a Newton meter is a joule, 6,000 joules. Okay? Now, let's note a couple of important ideas. This work is done by the pushing object on the pushed object. Okay, so the pushing object does work on the pushed object. This force, or this work, this force when exerted through a displacement parallel to the force, tends to deplete the energy of the pushing object. Okay, this object is going to lose energy as a result of pushing the resisting object. For example, if this object is coasting and moving very fast at the beginning here, it's going to be moving slower here. It will have lost energy of motion between here and here. And we'll make the idea of energy of motion more precise shortly. Okay, so this force tends to deplete the energy of the pushing object and add to the energy of the pushed object. Okay, as far as the pushed object is concerned, work is being done on it, and that will tend to increase its energy. Now, if it's resisting, the resistance might tend to decrease its energy, and maybe its energy actually doesn't increase, maybe it even decreases because the resistance is greater than the force exerted on it. However, we see that this force has the tendency of slowing down the first object and speeding up the second, or at least causing it not to slow down as quickly, tending to reduce the loss of energy, or perhaps to help that second object gain energy.